Hi, and welcome to another episode of Miles on Motion. I'm your host, Miles Budimir. In the last episode, we looked at the basic operation of several types of motors, including the most common AC and DC motors used in motion control. Now, let's focus on the feedback devices. Feedback devices provide information to the controller, typically position or speed, or both. The two most common types of feedback devices in motion control applications are resolvers and encoders. A resolver is essentially a rotating transformer that produces two sinusoidal signals. These signals indicate the absolute position of the motor. Electronic circuits convert this analog signal to a digital signal for processing by the motion controller. The other type of feedback device is an encoder. A typical optical encoder consists of a disc inscribed with lines or marks. A beam of light passes through these markings and is picked up by a light sensor, producing pulses which, when counted, indicate either position or speed of a motor and can also indicate direction as well. Encoders can be of two different types, either absolute or incremental. Absolute encoders have a unique code for each shaft position, while incremental encoders are relative in that the counting determines the position. So, for instance, in the case of a power outage, an absolute encoder remembers the position, while an incremental encoder would have to do a homing operation to remember the position. Because resolvers contain few electronic parts, being essentially two rotating transformers, their construction is more rugged. However, they can be heavier than your typical encoder. They can endure shock and vibration more easily than encoders, and can also withstand higher operating temperatures. On the downside, resolvers are more complicated because of the external circuitry required to convert the analog signals to digital signals. Optical encoders are lighter weights, offer better noise immunity than resolvers, and are also simpler to implement and interchange than resolvers. A major drawback of optical encoders is their susceptibility to contamination and damage from shock and vibration. However, some of these drawbacks are being overcome with the use of newer magnetic technologies. This is only the tip of the iceberg, and in future episodes, we'll explore the details of these and newer feedback technologies.